Hello learners, we will study determinants and property of determinants. Definition. The term determinant can be defined as a numerical value obtained from a square matrix of the coefficients of certain unknown variables enclosed by two bars by the process of diagonal expansion to tell upon a given algebraic system. Let a11 plus a12y equals to 0, a21x plus a22y is equals to 0. By eliminating x and y, we get the expression as a11 into a22 minus a11 into a12 equals to 0. Characteristics of determinants. From the above definition, the essential characteristics of a determinant may be analyzed as under: A. It is a numerical value. B. It is obtained from a square matrix. C. It is obtained from the coefficients of certain unknown variables, say x, y, z, etc. D. It is obtained from a square matrix enclosed by two bars in its left and right hand sides. E. It has a large number of algebraic properties. Cofactor. By the cofactor of an element of a determinant, we mean the product of -1 I plus j and the minor of the concerned element mij. Symbolically, it is given by Cij equals to -1 iota plus j into m iota j, where iota j equals to cofactor of the element in the ith row and jth column of the determinant. Minor. By the minor of an element of a determinant, we mean the subsquare determinant of the given determinant along which the particular element a iota j does not exist. It is obtained by deleting the row and the column on which the particular element a iota j lies. It is represented by m iota j, which denotes the minor of an element in the ith row and jth column of the determinant. Its value is obtained by deducting the product of its non-leading diagonal elements from the product of its leading diagonal elements. Properties of a determinant. First, if any row or column of the determinant consists of zeros only, then the value of a determinant becomes 0. Second, if two rows or columns of the determinant are identical, then the value of the determinant becomes 0. Third, the value of determinant remains unchanged even if its rows and columns are interchanged. Fourth, if any two adjacent rows or columns of a determinant are interchanged, the numerical value of the determinant remains the same but with the opposite sign. Fifth, if every element in any row or column consists of sum or difference of two quantities, then the determinant can be expressed as the sum or difference of two determinants of the same order. Sixth, if each determinant in a row or a column of a determinant is multiplied by a constant k, then the value of the new determinant is k times the value of the original determinant. Seventh, the value of the determinant remains unchanged if to each element of any particular row or column of the determinant, the equimultiple of the corresponding elements of one or more rows or columns be added or subtracted. Eighth, if the elements of any row or column of a determinant are multiplied in order by the cofactors c iota j of the corresponding elements of any other row or column, then the sum of the products thus obtained is 0. Thank you. See you in the next lecture.